Hi everyone. Our next video is pulled from one of my lectures in my Pharmacy Technician Certification course online. If you're interested in signing up, please click the link in the description box below for more information at www.thepharmaceuticalinstitute.com. In this video, we review additional sample certification exam questions from the text we utilize in the course. Let's begin. So to solve for these fill-in-the-blank questions, you want to set up a ratio proportion equation. We learned about the ratio proportion equation in this lesson, and we also, so there's two things I wanted to mention. One, we're going to learn about three different types of equations to solve for calculations, pharmaceutical calculations. And I want you all to take note of when we're learning about these calculations, if you latch on to one equation better than the others, I want you to memorize that equation and stick to it when you are taking your certification exam, because trying to figure out whether or not to plug in this equation versus that equation will become too confusing for you. And if you grasp on the one equation, but it may take you maybe 10 steps to get to the answer, far be it, so long as you get the answer right for one, and that's the way you understand. So even if the textbook is teaching you one way or a different way, if you grasp on to one of those ways better than the other, stick to it, write it down when you get to your certification exam, and just refer back to that equation. If you remember the other equations, go ahead and write those equations down as well, so that should you need them, you can refer to them, and that'll make more sense when we get into those calculation chapters. So in this lesson, we're learning about the ratio proportion equation, which is commonly written as grams per milliliter. So grams is the weight and the volume is per milliliter. And so when you're looking at a calculation problem, the second thing I wanted to mention is first identify your given information. Look at what has been given to you, whether you know how to solve for the problem or not. Go ahead and write down all the information that has been presented to you. Some of it may not be relevant, but so long as you have it in front of you and you can refer to it easily and it's not mixed in and confused into your sentence, into that word problem, and you have it just easily visible for you to refer to, I think that is best when you need to plug and play values into the equation that you prefer. So in question number 5, a 1/10 solution contains how many grams of active ingredient and how many milliliters of product? And so that's our first question in this this calculation. And 1,000 milliliters of that solution would contain what unknown grams of volume, what unknown grams. So our givens are, we do know that ratio proportions are written in grams per milliliter. Any proportion that's written as an unknown gram per 100 milliliters is equal to a percentage. That is not relevant to this equation just yet, but that is given information that we already know. You're just writing down information that I know based on what this equation is, what this problem is talking about. So the given information we also have is written as 1 part per 10, but we know that ratio proportions are written as grams per milliliter. So we interpret the first part of this equation as 1 gram per 10 milliliters. That's the answer to the first part of the equation. The second part, we actually have to solve for utilizing a ratio proportion equation to solve for the unknown the unknown value of grams. So we will set up, yes, we are right. 1 gram per our unknown grams. This is another way to write a ratio. You can rewrite it in the form of a proportion and set them equal to each other. So our first value that given information we have is 1 gram per 10 milliliters. set it equal to our unknown value of grams per 100 milliliters. Excuse me, 1,000. That's what the equation is. 1,000 milliliters. We're going to solve. You would cross multiply utilizing the ratio proportion equation. You would multiply 10 milliliters by your unknown value of X, and then you would multiply 1 times 1,000. So we would have 10 ml times X, unknown value X in grams. We will set that equal to 1 times 1,000 equals 1,000. But the grams do not disappear. So 1 gram times 1,000 milliliters will equal 1,000 milliliters per gram. Oh, I need to move this over. Yes, so it's not too messy. Next, you want to get rid of your milliliters because we're trying to solve for our unknown unit of grams. So when you need to get rid of a unit to get the grams by itself, you'll divide both sides by milliliters, and you're going to divide both sides by 10 milliliters. So once 10 divides by 10, let me go ahead and set that over here. When 10 divides by 10, that equals 1. When a number divides by itself, you get the value of 1. So that'll actually be 1 times X grams, an unknown value of grams, will equal that unknown value of grams. But over here, we have 1,000 divided by 10, which will equal, so we're left with our unknown value of grams, which will equal 100 grams. Now, what happened to the milliliters? Again, here, where our milliliter units divided by itself canceled out and became the number 1, our milliliter units here divided out and became the number 1 times the value of that gram. So we're only left with the gram, the unit of gram, once we divided out the unit of milliliters. Does that make sense? And so our answer to our second question within this problem is a solution that contains 1,000 milliliters will have 100 grams of active ingredient per 1,000 milliliters of solution. That is how you solve for that problem. You will utilize the same method to solve for problem 6 down here. So problem 6 reads, a 1 part per 100 solution contains how many grams of active ingredients and how many milliliters of product. And then question 2 in problem 6, how many grams are found in 250 milliliters of that solution. So again, let's identify our givens. We know that a ratio proportion is written as grams per milliliter, and we also know that any proportion is written as an unknown value of grams per 100 milliliters actually equals a percentage. That will become valuable in our next problem. Next problems are next 2 parts of the practice exam. So I think these are too high. Yes, this part right here actually should go way down here. We'll put it right here. Okay. We know that we actually have a 1% based on the information. 1 part per 100 is actually 1 divided by 100 actually yields us a 1% solution. That's not relevant to the question, but is information that we can discern from what we have. So again, the information that you get from the question may not be relevant to solve the problem, but at least you have it should you need it you don't know if you needed to know that you don't know if you needed to know the percentage of this problem, but you have it ready should you do need to utilize it to move forward to solve the second problem. So the first part of the question reads 1 gram per 100 milliliters of product, because we know that any proportion is written as gram per milliliter. And then we'll solve for the second part of the problem. We'll set up the same ratio proportion equation. 1 gram per an unknown value of grams we are given 1 gram per 100, and we need to solve for an unknown value of grams per 250 milliliters. When we cross multiply 100 times x grams, that will yield 100 milliliters x grams. Set that equal to our second value of 1 gram times 250, which will yield 250 milliliters per gram. Next, we need to divide both sides by the value that is on our unknown value side of the equation. So we need to divide both sides by 100 milliliters. Now, a trick, not a trick, just something, a force of habit that I've always done. I just write the 100 one time. I don't write it on both sides every time. I did it previously in the previous problem to show you the numbers and how where the numbers fall, so you can see where they come from. But you kind of learn to take some shortcuts, and this is a very tiny shortcut here. It's extra effort to write that 100 twice, especially if you're handwriting it. So I just draw a solid line under both values, put the 100 because I'm dividing both sides by 100, and then I will write my final value, my unknown variable of grams, because the milliliters, 100 milliliters divided by 100 milliliters equals the value of 1 times the unknown value of x equals x. And then, let me line that up better. 250 milliliters divided by 100 milliliters cancels out the milliliter unit, so we're only left with the unit of grams, and that will yield 2.5 grams. So the second answer to the second question of problem 6, 250 milliliters of that solution will contain 2.5 grams.